Hello, this is going to be a little demo. I've tried to record this a couple times, but I'm not used to recording anymore. This is going to be a more contrived version of an off-the-cuff thing, a conversation I had with my wife earlier today. We were talking about 2D platformers and 2D platformer physics, and so while we talked, I programmed some simple 2D platformer stuff. And it went so well that afterward I was like, oh my god, I wish I recorded that. That would have been so perfect. So here I am recording. So we've got a simple application setup with a bunch of top level functions. Startup, process events, process frame, draw frame, after frame, and shutdown. And so each one of these has some stuff in it, right? We have some stuff in there, and you can do stuff. And the reason that these are different files is because we have module level hot patching. And so what that means is, let me go and run the thing. So I'll get my compiler, and we'll run our game. And here's the game. Here's the little game, right? And it's just got a grid, and the snapping is going to drive me totally bonkers, oh my god. But yeah, so here's our little quote-unquote game, right? It just has this grid. And if I go to the draw frame function, here you can see the code that draws this grid, right? So we clear the renderer, and then we draw, we get the window size, and then we set the color, and then we draw some horizontal lines, and we draw some vertical lines, right? So, you know, if you wanted to make the grid smaller on X, you could come in here and you could say 8. Sorry, smaller on Y. You could come in here and do something like that. If you wanted to make it, you know, 64 pixel grid, you could do that. This game is going to have a 24 pixel tile size, so I'm going to set these both to 24. If we wanted to change the color, of course, we could do that. So I'm just going to leave the color a little bit more muted. And then I'll show you what I set up for state. So the basic, what I tend to do in everything that I make is I have this idea of a runtime. I do this all the time in C. Excuse me. I'll do this thing in C where it's like I have one big struct that owns all of the runtime state for the application. Even things, you know, even if something is large and gets allocated later, you will be able to find it in this one big runtime struct. Having everything organized that way just makes life much easier for me, especially when I'm debugging, because it's a hierarchical like breakdown of the entire program, and I can just like delve deeper and deeper into it in the debugger and things like this. It's just really, really useful, right? So I'm doing the same thing here. We have a platform object that just has these little bits of SDL stuff. And then we have gym, which is the interesting thing. So this is a totally fresh code base. I haven't, it's like I have my SDL3 binding, but I have not done like a vector library or anything yet for this game. So I've just got these simple structs here. And then I've got an enum for some button names. I've got inputs, which is the Boolean state of those buttons, their old state on the previous frame, and then timestamps for when they last changed. So that you could, in theory, check something like how long has this button been held down. But there's no code like that in the code base right now. And then there's what we're going to call a level for this test, which is just a width, a height, and a pointer to some bytes. And a nullable pointer to some bytes. And so the gym has a position, velocity, acceleration, and we don't really need size actually, but it has these for the player. And then it has a level, and then it has some inputs. So with that, we should be able to make something. So the first thing I think we'll do is we'll go draw the player. So I'm going to label this, draw the grid, and then I'll come down here and we'll say, draw the player. And the player is just going to be an SDL rectangle for now because I didn't bring any sprite sheets to this whole thing. And we really don't need to have the player size that's in the runtime, so I'm just going to pretend it's not even there. Let's say that we're 20 pixels wide and we're going to say 30 pixels tall. That feels maybe silly. I don't know. Because 48 would be, let's make it 40 so that you have some like room above your head, but not like, it's not super duper forgiving. Not that it matters yet, we probably won't get that far. So then we're going to set the draw color, and we'll send the renderer in there, and then, oh my goodness, where are my hints? Why is my LSP not working? Whatever. So we need to set the color. We're just going to make it a white cube for now, and then we'll fill the rect for it. So we're going to set an STL frect in there, and this frect is going to be the position, the player position, the X, and we're going to make it the size divided by 2, and then we're going to do the same deal for the Y. Actually, no, we're not. We're going to subtract the entire Y so that the player's origin is down at their feet, and then it'll just be the size X and the size Y. And we can have a trailing comma because we're not insane. So you'll notice that this time I saved and our DLL got reloaded, or our dilib rather, on this platform, and nothing showed up, and that's because the player is at 0, 0. So we're going to go to, we don't want to restart the game and give like a starting position, so we're going to go in here to our input events, and we're going to get some input. We're going to get a key down event, and then based on that, we're going to go and reset the player to a place that's on screen. So we'll say reset the gem, and so we'll say if event key. Actually, we could do scan code. Why not do scan code? Is STL scan code R for reset. So we'll get the position, and we'll set it to a new vector 2, which is going to be at, so it's 24 is the tile size, right? And we could pull that out to like a constant or something, but for now we'll just do it this way. Let's say we're going to go 8 tiles over, and we're going to go, I don't know, 2 tiles, 3 tiles down, I don't know. So I'll hit save, and now we're back in the game. I'll hit R, and there's our rectangle. Fantastic. Best player I've ever seen. Okay, so there's our player. And now we'll go back over to, let's see, what should we do next? So now we have a player, and the player's drawing. So next we need a level, right? So the simplest thing to me, because like I am in the process of making some stuff, we could go ahead and try to like load a level editor format or something, but I'm going to keep it simple. I'm going to make just like an image. I'm just going to make an image, and then we will load that image. So I'm going to make a new file in a sprite, let's say, and it'll be, I don't know, let's say that it's going to be like 100 by, I don't know, 20 is fine. Yeah, sure. So now we have this long strip. I'm going to get some white and fill it up with white, and then I'm going to get black, and black is going to be the solids, right? So I'm going to load this image as if it's a level from a tile map editor. So I'm just going to come in here and like draw the ground. Come in here and draw the ground, right? And then maybe there's like some definitely not Mario Brothers blocks right here, right? And definitely not anything like that. And then there's maybe like a little hill or something, or a platform. And maybe we have another one that's taller. And I don't know, maybe we've got like a thing up here for later if we get far enough. But yeah, so let's say we have, oh gosh. I didn't think about what would happen when I hit save. I'm gonna have to censor all of my file names and crap. Dang it. So we'll go save a file. So we'll go save a file. We're gonna make a new folder in this called assets, and we'll make a. Actually, I can't. I was like, well, I could go into list view and then show the finder, but no, I can't because there are spoilers in my pinned files for all kinds of things. So I'll just make a new thing. I'll call it assets and gem, and then I'm gonna save this in there as a PNG called like test level.png. Okay, that was all off screen. So then we've got this. I'm gonna move this guy down here. So here's our little thing, right? Here's our little level, and here's our little game. And then up here we will, let's see, what should we do next? So let's go to, can I just like drag this off? Yes, I sure can. Okay, so let's go to draw frame, and should we do the rendering code first, or should we do the actual loading code? Let's do the loading code. So if we go look at the runtime, and we look at what a level is, it's a width, a height, and a nullable pointer to some bytes. And so what we're going to do is, on process events, when we reset the gem here, we're just going to also reset, we're going to try to load that level. So let's see, load the level PNG. So let me run up here and import, not STL, Jesus, PNG. Okay, we're going to import the PNG decoder, and we'll come in here and say let image equals the PNG decode file. We could do or dummy if we care about. Yeah, we'll do this. We'll do it this way. And then we'll need a C string. I should really change that API. And it'll be at assets gem test. What is it called? Test level.png. I think it is. And so then we can assume that the image exists. Also, we need to, let's see, or well, yeah, you know what? Let's get rid of that or dummy. We'll just do it we'll do it the C way, the typical C way. And so if the image, if we got a non-null pointer back, then in there we will free the image itself at the end. And then if we already had like loaded tiles, then we can free that as well. If I could type anyway. If we already have some tiles, we'll go ahead and free them. Jesus, where's my mute button? I'm not professional anymore, and it's allergy season. But so what we're going to do then is, so we just loaded the level, so we're going to get the level and we're going to set the width is going to be the image width. Why is my autocomplete so janky? Height is going to be the image height. Just like all kinds of junk all over the place. And then the actual tiles, so we're going to allocate the tiles. The tiles are just going to be booleans for now because it's going to be solid or not. And it's going to be the width times the height of the image. And then we're going to try to get the tiles. So we're going to get the tiles, then it's going to be the so assuming the allocation didn't fail, and why would it have? What is this? Yeah, I know. Okay, so if we do that, now we're going to go through all of the pixels of the image, and for each pixel we're going to see if it's black or not. So pixel is black. And so what we're going to check is if image pixels, and these are just, this is just a U8 pointer, I believe, yes, U8 pointer. So that's going to be the x times 4 for 4 color channels plus y times the width of the image times 4. And this is the 0th byte of that pixel. So we want it to be 0 because this is a black pixel, right? And then there's the next 2 color channels, and then finally at the end we want the alpha to be 255. So we'll check that, and so then that will determine if the tile is solid or not. And so if you haven't seen this before, the reason I'm doing this is because if you want to map like a 2D grid onto a one-dimensional array, then if it's you know, if you go left, right, top to bottom on the image, then the y coordinate you can get by just multiplying by the width of the image. So we're doing the same thing with our tile map, and we need to cast this boolean to a U8, because actually, can this be a U8 or would I have to cast this? That's the real question. Pixel is black, thank you very much. I'm not sure if that will work or not. And of course we could really skip that and just put, but this is more clear. Anyway, so there's that. And then let's see, if we couldn't do this, then we could say else, and we could print like some error where we're like, we could be like ePrint, and we could say couldn't allocate tiles, right? Say something like that. And then if we couldn't load the image, we could do the same sort of deal. If we wanted to, we could say ePrint error, couldn't load image, which might be the case. Like I could have easily misspelled the file path being in a hurry. So we'll go ahead and save this. It doesn't rebuild, we have a problem. What is our problem? Type mismatch. Okay, yeah, so that didn't work. That was a problem. So we'll make this a boolean, and we'll come down here and we'll cast this boolean to an unsigned byte. And now we can hit R, but of course nothing will happen, right? We don't know if this is succeeding. We didn't get any errors printed, so presumably not, right? What is this problem going to be? Unused import. Yeah, whatever. If they included the header in SDL, I include the module in my thing because I'm very smart. Alright, so let's go back to drawing the frame, right? And now we will draw the tiles, right? So we've got the player drawing. Let's come and draw the tiles. So we're gonna have a different draw color for this. And it's gonna be, we want it to be greenish probably. So maybe we'll take some like red off of it, and we'll like take some blue too. It'll just be a little bit green, not too green, but a little bit green. And then I think we'll just iterate through and we'll draw them. Like we don't have a moving camera or anything right now in this, so same deal. So we'll just go through all of the Y, and that'll be in the height, and then we'll go through the X's in the width, right? And then in there what we'll do is we'll say if the tile is, so we got to do that index trick again. So if the tile is non-zero, then it's solid and we're going to draw it. So we're going to fill a rect here, and it's going to be an STLF rect. Oh my goodness. And it'll be at the, I'll have to cast these, so it'll be the X times 24, and actually we just do that in here. X times 24, and then it'll be the Y times 24, because that's our tile size, remember? And then it'll just be 24 for each of these, for the width and height. right? And then if we save, oh my goodness, there's our tiles. What is that? Is that our tiles? Why yes, I think it is our tiles. So now, if we go back to a sprite, you can see here it is, right? And we could go and draw some more tiles and save, and then come over here and hit R, and there's the changes, right? Because we just have it set up to reload whenever we hit R. We can go add anything we want in this image and reload and get it. But yeah, so there's that. So now we can add some, let's add some physics to this guy. So we've been doing a lot of drawing stuff, let's add some physics. I'm going to make this a little bit smaller so it's easier to see the code. And then we'll go to process frame, which we haven't touched so far. Process frame, we haven't done a single thing in there yet. So let's, okay, first things first, let's do some gravity, right? So for gravity, we'll get the velocity, and for the velocity, we'll take the y, and currently y positive goes down because we're just doing the render coordinates here. So what we'll do is we'll pick an arbitrary number and see how it looks. And so then what we'll do is we'll get the position. I don't know, my autocomplete is totally borked. I found a bug in it earlier on a prior session and fixed it, and now it seems to have messed up other things, and I'm very cross because it was quite fancy before, but it normally works. I don't know what I broke. So the position is going to be plus equals, and then we're going to get the velocity. Oh my god. The velocity times, we're running at, actually I think we're running at 100 hertz, but let's just call it 60 for now. We could get our actual, I haven't set up like a fixed time step, you know what I mean? So we're doing a little bit of erg. Okay, and so as you can see, there's our, and it's getting faster and faster, and it's getting faster and faster because we're not resetting, we're not resetting the position when we reset the other stuff. So I'll make one for velocity and one for acceleration, and then we're just gonna clear these out completely. And now when we refresh, it starts falling from no acceleration again, no velocity again. So that's good. Let's now we've got some gravity. Let's go and do collision detection. So rather than just add the position like this, we're gonna do sort of what a lot of games do, like 2D games, modern indie 2D games and stuff will do. Which is we're going to separate the velocity by axis, and then we're going to step by whole pixels and see if we hit anything. That's how Celeste does it. So typically when I'm doing a game that uses this, I refer to it as Thorson physics, even though it's like a very old idea that is very commonly used. I call it that just because I don't have a good reason. So let's say collision, detection, and movement. And then what we'll do is we're gonna have like a frame velocity, right? And the frame velocity is going to be, it's going to be the x velocity times, we're pretending that this is running at 60 hertz, even though it's actually running at 100 hertz, oopsie daisy. So we'll get our frame velocity there, and then we're going to split it by axis. So I think I'm going to need the math library. Math, okay, yes. So we have move x, and we're gonna have to do some casting, because there are no implicit narrowing thing. You have to do this sort of thing. Like the things that are warnings in C, I've tried to elevate into compile errors where possible. So this is, we're rounding it effectively. We're adding half of a pixel, and then we're casting it down to truncate it. So we're effectively rounding it, and so we're getting a rounded velocity, And then we're going to have a step x and a step y, and these are 0 initialized by default. And so then if we're moving left, right, then the step on x is going to be negative 1.0, right? And if we're moving right, then the step is going to be positive 1.0, right? And then we have the same deal for moving up and down, so I'm just going to change these to y's. And so now what we're going to do is we're going to loop through on each axis to do the motion, and it should be roughly the same motion. So like now we're not doing any motion because I commented this out, right? If I uncomment that, there you go. So there's that old movement. Now we're gonna recreate that. So we'll have x delta in 0 abs I32 is what we want. When we move x, then we'll say we'll add the step on x, right? And then we're going to do the same maneuver on y here. So we'll have the y delta, and then this will be move y, and then this will be y, and that'll be y. And now if I save, we have pretty much the same movement from before, except we're now only moving in whole pixels and kind of rounding to the closest one, which for a fast-paced platformer makes a lot of sense. We might get in trouble later if it's like, oh, we're moving really slowly on a platform or something. We might get some like ugly aliasing happening with that or something, but we can worry about that later. So then one other thing I would like to do is I would like to round the player position at the end of the frame. So we'll get so that she always shows up on like a specific pixel. A lot of modern pixel games let you stand on like a half pixel, and it's fine, and it makes the movement really smooth and everything. But I just like to, particularly if you're not moving, so like later, make it so we only do this when motion stops. Because you don't want your player to stop and then you're like trying to take a screenshot and you notice that like, oh hey, the like pixel of her shoe is halfway on the pixel of this grass tile or something. That drives me bonkers. Like during gameplay and stuff, it can feel really nice to have that subpixel motion for free, but if you're trying to get something that looks like pixel art and things are in between pixels, it can be kind of rough sometimes, and how that looks varies a lot by game, but we're going to solve it for now by rounding at the end of every frame. So now it's really zoomed out so you can't really tell, but it's on whole pixels. So now we're going to do actual collision detection on this. So what we can do, one of the reasons that this is split by axis is so if we hit something on one axis, we can zero out velocity in that direction, but leave the other axis unaffected so you can slide along like a corner or something in a natural way. So what we're going to do is we're going to go and we're going to look at the tiles, and so basically every pixel that we move, we're going to go we're going to go look at the tiles, we're going to sample the tiles, and if the pixel that we're moving into is in a solid tile, we don't move into it. Or we could check the current position so that like our foot pixel can get inside the solid, but no further, and that actually later that could make it easier to like detect it, like, oh, we're standing on a moving platform or something. I don't know, you could just do your foot position +1 down, right? So like what difference does it make? Anyway, so we're going to figure out what tile we're on. So we're going to get, let's see, so it'll be the gem pos x divided by 24, right? So that'll be the tile on x, and this will be the tile on y. And so then we can get the tile index, right? So we're gonna get our tiles from the level, and then we're gonna get the tile index, and really we could just put this whole thing in here. So we're just gonna get the tile index, which is gonna be tile x plus tile y times gem level width, right? And then we'll say if in the tiles at the tile index, if it's not 0, that means it's a solid tile. We're just gonna break out of this loop, and we'll break out of the loop. Otherwise we'll keep moving, right? So I'm gonna take this and just copy paste it down here. And now, ta-da! Our character lands on the ground. Isn't that nice? And so that's with doing it like where you check the current position. If you wanted to change it, what you would do there is you would be like, oh, well, you would do like this. You would like add the y velocity there. Not that. Sorry, step y is what you want. You'd add the step, and you can see now there's like 1 pixel between. But yeah, we don't really care about it for now. Oh gosh. So we're just gonna do it this way. So there's our critter, and we're falling on the ground, and if we were able to move horizontally, we could run into the wall. So let's go and make it, actually, let's pull this stuff out into a function, and then we will go and then we can go and do the motion. We can actually get some keyboard input. So we're gonna basically do the same exact thing in here, and then instead of this part just goes away, so it's x and y, and then we do the same. Instead of break, we would do return true here, and here we would return false. So now we've got that, and it's an unused function. So we're gonna come down here and say like, come down here and we'll say if is solid at pixel, and it's the RT, and it's RT gem pause x, RT gem pause y. Then we'll break, otherwise we will keep on moving. And eventually what we could do is in here we would be like, well, what did we hit, and what's all the, you know, we're gonna make these floats, and then we don't have to cast on this side, we can only cast in there like we were doing before. Okay, sweet. So there's that. This is unchanged. Not a lot of code for this type of stuff. Making a fun game on top of it is hard though. So we've got that. So next, let's try to work on some inputs. I need to take a drink really quick, so I'm gonna mute for a second. Alright, sorry about that. I am drinking Diet Sam's Cola, and let me tell you what, it makes a girl belch. Like, it really, the amount of belching going on is insane, so I apologize in advance if that comes up, so to speak. So what else? So we've got collision detection and movement. Now we need to do some input. So we're going to add a key up in here as well, and then I'm going to put this at the top so it's kind of, so we're going to say do check inputs, and we'll also do a check inputs down here. And then the way that it happened, I should have brought, I mean, I did bring water, but I didn't bring a straw, and I don't want to be like gulping water on the mic. But anyway, so what we'll do, we have some inputs, right? Here we have some inputs, and we want to monitor these, and we want to have some tell you what, I'm going to make a debug draw for this first, because actually that will make life much easier for me. So let's go to the draw frame, and we're going to come down here, and we're going to do debug draw inputs. And so we're going to say for, I might have some trouble here, we'll see. I and 0, and then it would be like, what is it, like button count, is it called count? I don't remember. Autocomplete, you're not helping me. It's called count, yeah, okay. So we'll go up through those, and then we'll say STL, actually we should set the color here, so we'll say STL render draw color, and it's gonna be, let's say it's like, I don't know, 200, 200, 200, 255, let's say that it's reddish, I don't know, fine. And then, what's the problem? It is an integer. You fool, you foolish fool who is foolish. That's a compiler bug. I need to write that down. Anyway, pretend that that works. We got 4, 8, 9, 10, 11, 12. So we're going to say 12 for now. 12. And we're going to say fix me. Compiler bug. Range won't take enum as integer. Not good. Not good in the demo. Not good. Alright. So there's that. And then, let's see. So then we need to do, I mean, I could cast it. I could be a total jerk and just like cast it, right? Like, so at least it's clear what we're trying to do. Button, count. Will that work? Yeah. Why is this a problem? Not get. Oh my goodness. Okay. So there's that. And looks like we're good here. Okay. Back in business. And then what we'll say is for each one of these, we're just going to draw like a little rectangle. We're going to draw a rectangle. Sorry, it's just called like rendirect now. Yeah. Rend. STL frect. This needs to be a pointer. Okay. And it's going to be at like, let's say we're going to do this like 8 pixels from the top. And then for each button, it's going to be like times, I don't know, let's do times 16. And then for the size, it's going to be like 12 or something. I don't know, let's see how that looks. Okay, that's not so bad. Those are going to be our inputs. And then if the input is down, if the input is pressed, then we'll draw the same rectangle but a little bit smaller. So we're going to add 2, and then that'll be like -2 from each side, so -4. And then, so that means, well, wait, based on what, buddy? Also, it should be filled, but I'm not sure why those are filled. Am I stupid? Can I not count? 4, 8, 9, 10, 11, 12. Okay, well, I'm sure that that's not good. I guess we'll find out why that's the case. But anyway, so is this more than 12? Am I insane? Okay, first of all, it is more than 12, which is not good. This should be 0. This is 0, right? Like, am I crazy? Oh, and these are U16s. That could be part of it as well. Oh, I can't change that or I'll get in trouble. Well, whatever. That doesn't matter, actually. For what we're doing, that part shouldn't matter at all. Other than I can say that this is a U16. Alright, we're not having that apparently. Well, yeah, duh, of course not. Will that be allowed? Yes. Does it fix the problem? No, it doesn't. It would have been widening before anyway. But yeah, so that's weird. That's something to find out later. Fix me. Why are the inputs showing on in the top 5 slots? Are we overrunning somewhere stupid? Question mark? Okay, so there's that. So anyway, here's our little debug draw inputs. We're going to call that good enough. Let's go over here to this. So now we need to actually check those inputs. So we're going to get the event key scan code, not case, switch. And then STL scan code left or scan code A. So we'll do WASD and arrow keys here. So we'll have that, and then it'll be, so left would be, so we'll say if, not game gem, input, buttons, if the buttons, and it's going to be button left, if not the button, right, if the button is not pressed, then we want to press it, and we want to set the when it was changed to be the current tick. So we're gonna get we're gonna do cast f32 stl get ticks divided by 1000, right? If I could write. Okay. So that'll give us the millisecond, and we could do nanoseconds there. I'm just not. This will be fine for now. We might not even use it before this is over. We need to add a default case because it's an integer type. So we got this, and actually that's kind of ugly. Let's do I don't know. It's fine. It's some wide code. A little wide code never hurt anybody. So there's that, and then is there anything else we really need to do there? Maybe not, maybe so. Anyway, so now we're gonna do that for the others. So we're gonna have right and D, and instead of move left, it's gonna be move right, and then we're gonna do up and down. Up, and that's going to be W, move up, and then we'll have move down, that's going to be S, right? So move up, move down, and then I'm just going to copy this whole thing down here to raising the key back up, and we're just going to change this. So we're going to grab all these nots and delete them, and then we're going to grab these trues and change them to false. And that's what we're doing. And so that should give us so there, now you can see I'm hitting the arrow keys and I'm hitting WASD, and there's our stuff. And would you look at that, the first slot appears to be for none. Duh, I'm so stupid. Oh my god. Of course it is. It's 0, not -1. Maybe it should be -1. Maybe none should have been -1. Anyway, so now we've got arrow keys, right? And that's something that we can now play with. So now that we have some arrow keys, we're going to go to process frame, and I'm going to have player input, right? Excuse me. So here in player input land, let's see what we'll do. So we're going to check left and right, and we need to have like a max velocity or something. Player max run speed, let's say it's going to be like, I don't know, 150. This is an arbitrary number. And then we'll say player jump impulse. We want to ultimately have like you hold down A or whatever, but for now we'll just make it like a straight up value. And then we'll have like player damping when you stop moving, and I don't know, something like that. And then what we'll do is, so on a given frame, oh man, I have not really thought this part through at all. So we'll say, so if we go to our gem and we'll get our velocity, this is going to go very poorly. Actually here, we'll do it this way. So we'll say x. We're gonna make a scope here for this so that we're not just like polluting the rest of the function with this stuff. Okay, so we're gonna have attempt move x, or well, here's what we'll do. We'll have player intent move x, which is going to be the it's going to be the input, and it's going to be buttons if the left button is down, right? Button move left, and then actually I don't know if that's how that would work. I don't know if I've got my bool casting good. I could do if as a thing maybe, so that'll be and actually this should be right, move right. So if move right is true, then that'll be 1, else that'll be 0, minus move left, and that might be fine. Player intent move x times, I don't know if we need to do that or not, we'll see. Maybe not, maybe not. Okay, that seems to be making no difference whatsoever. Oh, right, because where the foot is embedded in the ground already, even if this is correct, it wouldn't move. Let's go ahead and do the Y, and then we'll take a look at that. So we'll move on Y, and this will be move down. Well, we don't really need to move on Y, we just need jump. This is a platformer. I'm not making a top-down game. Who would ever do that? Let's just make double sure. Yes, okay. So then we'll come down here to this, and I guess it should be if the, well, that would mean we could move in the air, right? In theory, and it sure doesn't seem like we can move in the air. The speed might be too slow. This could be a mistake. Am I stupid? I'm probably stupid. It could also be that the code gen on this is bad. So here, we'll do this. We'll do F32, player intent, player move x, player input x, and player input jump, let's say. So then we're just going to grab this. If we're moving right, then the player input x is going to have 1 added, and if we're moving left, then it'll have 1 subtracted, and if, why is my indent so screwy? And if they do, this isn't programmed at all, it would be like action right probably for the jump. Player input jump. Probably be like 1.0 or something. And okay. So now, right, we don't need this anymore. We'll use this, and we're still not doing any movement. Are we actually applying that somewhere? Yes, we are. Allegedly. Are we actually moving on X at any point? Seemingly not. Wait, rebuild failed. That would explain a lot, huh? What's the failure for? Well, these are warnings. We're allowed to have warnings, my guy. I gotta have better formatting for these. Line 23. What's the problem? That's all copacetic, my guy. Oh, that should be minus equal first of all. Okay, that's okay. Okay, now we're in good shape. And then we do get stuck when we hit the ground, like totally stuck. Okay. Ay. Doing it live is hard. In front of a live studio audience. And it has very, like... Okay. So anyway, there's that. And then down here we want to change this so that it's going to be the X plus the step X that we check. And this is going to be the Y plus the step Y that we check. And now we can run around on top of the ground and we can slam into things. And we're actually not checking, we're only checking the bottom center, which is why we can slam into the wall like that. We're also not negating the velocity, so it's like I'm still trying to move fast when I slam into that, and then I have to hold left for a long time until I get off of it. I fell off the end. Whoops. So let's go and let's make it a little bit better. So we're gonna have check X is going to be plus, and it's going to be the step X times the check edge, we'll call it. It's going to be the step times the half width of the thing. So it'll be player size, which we don't have in this part because it's in the rendering. We made the, how big did we make the player? We made the player how large? 20 by 40. Okay, so that'll be times 10. And we'll note player half width. Okay, so there's that. And then here, instead of checking this, it will be the check edge that we put there. And ta-da! Now we slam right into that thing. And also we need to make it so that we reset. When we hit a wall on an axis, we take our velocity away on that axis. Okay. Really, we should do something more complicated. We should let you move if you're moving out of a collision, but if you're moving into a collision, then we should not allow you to. But for now, this will be good enough. So now I can do this trivially. Yay! And then we need to do the same thing with Y. So we'll do the same sort of deal where we get the leading edge, so it'll be the Y. Right, the Y minus, what was it? Was it by 40? Yeah, 40. So minus 20. So this is because the foot, since our origin is at the foot of the player, the very bottom center, we want to go halfway up, since we're going to then apply the offset the other way, right? Is that correct? Yes. So this moves us to the center of the rectangle, and then this moves us to the top or the bottom. And then this needs to be the check edge. Okay. And then instead of just breaking, we will zero out the y velocity. Okay. So there's that. And now what we can do is, I fell off the edge again. We need to add a jump in here, so let's go in to this part, and we'll do the same deal as we did on all of these freaking things, but we'll add another one. We'll say SDL scan code space, and that one will say, we're going to copy this because we are lazy, button, action right, what is it, action right, and action right, and that'll be fine. And then we're just going to copy this and bring it down here to the key up version, where we take the not out and we make it true, false, make it false. Okay, so now if we got that, now I can hit space and it lights up that input. So now we're going to go over to process frame, and I'm going to do the jumping, right? And then none of these are even used yet. But here's the most naive thing, right? We'll comment them out for now. And then we need to say if, so we're gonna like bool is on ground, which for now will just be true. If is on ground, and bool pressed jump is going to be RT gem input buttons. If we're on the ground and and you'd want to make this dependent on like the run speed and all other kinds of things, right? But so if we're on the ground and the buttons of button move right, if that's down and not the if it's down and if it wasn't down on the last frame, now what we'd really want to do here is you'd want to have like a buffer. You'd want to say if it was pressed within the past 10 frames and we're on the ground, then maybe you've like buffered a jump, right? And we let you jump. But for now we'll try this. Buttons old, right? If is on ground and press jump, then Y is gonna have like, I don't know, let's just say 200, right? Right, we need to detect the press, right? So we need to go to our update frame, right? Where is it? Or after frame, we go to our after frame work, and in here, you could say prepare next frame for inputs, and then we could say gem input buttons old equals RT gem input buttons. Ta-da! And so then, no, you turd. Why not? Okay, let's see. Print pressed jump. Okay. 0. Well, never gonna find it at this rate, huh? Let's maybe put a new line on the end of that. Nope. Is this going to end up being a bug? Fix me operators are messed up. Messed up for some reason. There's a unit test for this, and it passes. So what? Which particular thing is it about it that's like broken? I don't know. What if we do some crap like this where I'm like, no, that doesn't work either. Okay, something is amiss then, I guess. Are we setting it correctly in process events? Either, which is maybe indicative of something. Oh, because it's plus. Because it's plus. Because it's plus. This is why. Oh, good gracious. This is why you fix your coordinate system before you, Okay. Well, now we can mess with this until we find a fun value. Whoop. Oh, Lord. That is so squidgy. We need to have, we are not actually applying the damping. That's not good. We need to do that. So wherever we damping times equals damping, which we don't have anymore. Okay. That feels a little bit. Oh, it doesn't feel slidey enough almost. It's like you're not fast enough to start moving, and then you're too fast to like. Also, we need to actually check the whole leading edge, like check the top and the bottom or something. Or write actual physics. We haven't written any actual physics yet. We're just doing like a magic pixel at the feet. So that's why we can hop up here and go under this like this. But yeah, let's make the camera follow us so that we can go over and look at our other cool. Oh yeah, I forgot, we can just jump in the air right now because we don't actually check if we're on the ground. So that's something we should do. Let's check if we're on the ground. And this is going to be silly. Is solid pixel, and that's going to be for the record, despite potential compiler bugs that I have found, I have nevertheless gotten substantially farther than I got earlier, because earlier, so I can't jump in the air, see? Earlier I hit a bug much sooner when I was looking at the array of buttons, so this is better than that. Let's see, what else do we want to do? So now we want to have, we would like to move the camera. Oh no. I don't get momentum yet, so I can't do that jump. Okay. Let's go and move the camera. To do that, I think I need to stop again because I need to edit the runtime. I need to add something to the runtime. Instead of size, we could call this camera pause. Actually, here's what we'll do. Do struct camera. And camera cam. And it just won't reload, of course, because it can't, and we're gonna have to restart. I need to have like a warning for that, like, hey, you edited a struct that you can't edit and reload because we're not patching it up for you. and have it like gracefully tell you to restart. That's something that something we should have. So anyway, here's our little box, and let's go make the camera follow our little box real quick. Oop. Why are all those like starting out true? They shouldn't be starting out true. All the inputs. Anyway, let's go make the camera work. So what we'll do is on the draw frame, on the draw frame, we'll say if you we need to offset the camera, and I don't think SDL lets you just arbitrarily offset the camera. I think you have to offset everything you draw. Am I crazy? Hang on, let's look. So we're drawing our grid. SDL translate, no. Offset, scale, no. You can set render scale, that's a thing. Set render offset, no. Clip rect, scale, target, viewport, vsync. Okay, yeah. Can't do it. That's fine. So what we need to do is we'll say cam x is going to be cam x, cam y. We'll get the two camera coordinates like that, and then this is going to be those need to be offset by the like little bit that's like different, right? So these need to be rounded first of all, probably. Well, I like letting them scroll smooth, honestly, but we'll have to round it for these is the problem. Sorta. We need fmod. We got math in here. We need some fmod, if you know what I'm saying. Okay, so the grid's gonna have kind of some offset on each one of these, so we need to do, oh goodness, I wish my brain worked right now. So we're gonna have grid y off is gonna be like the camera y, sorry, it's gonna be fmod, and it's gonna be the camera y, and it's gonna be the tile size of 24, and it's gonna be that negated, and then it's gonna be y plus the grid y off, and I want to say that's correct. Of course it's 0 right now, so we wouldn't be able to tell anyway. But having written this sort of thing a few times in my day, I want to say that's correct, eyeballing it, but we'll check here in a second. So there's our one line, and then we'll have the grid X off, which is the cam X version, and then I want to say that that's correct. And then on these X ones here, we'll do plus grid X off, and now we'll format this semi-readably. Okay, so there's the grid, and it looks the same as it should for now. And then to draw the tiles, we gotta do the same deal. We're not gonna cull or do anything clever here. We're just gonna draw all the tiles, and we're gonna offset the positions. This will be minus cam x, and this will be minus cam y. And that should be all we need to do for that. And then for the player, it's going to be the same deal. Minus cam x, minus cam y. And then for these, we leave them glued to the screen, right? So they're basically like a HUD element. So we're going to leave those. And then here we're going to go to... and we need to do the actual camera following now. So we're going to go to process frame. And so after we've moved our player and done our collision and all that, we're going to do camera follow player. So we're going to have the camera dist x, or well, so here's what we'll do. Cam target x is going to be the x position of the player minus, oh gosh, we need the window size. Do we have the window size? No. Window width, window height, STL, get window pixel, or get window size, right? Platform window, and then what else does it take? Yeah, it takes an I32, so I remembered correctly. Okay, and then minus, and so we'll have window half width is going to be half width, and we'll say cast F32 window width divided by 2, and then we'll say F32 window half height is going to be that, and then so the cam target x is going to be our position x minus window half width, and then the cam target y is going to be y minus window half height, right? So we'll get that, and then after we've done that, that's our target, and then we need to like lerp the camera towards it. So we're gonna say, currently we're just gonna like straightforwardly, do I have a lerp? I do. This is not a great way to lerp. Don't do this, you kids at home. This is frame rate dependent, and you should use POW and do other cool stuff. But now we have a moving camera. And actually, this is a platformer. You don't want your camera to bounce around like this in a platformer. What you'd really want is something more like, you would like to be able to have the camera show you the ground a lot of the time, and then move up when you land on a new platform or something. So one way we could do that, we could just turn off the we could just turn off the Y-lerping or something, and then turn it on when you get to a certain. So we could do this. We could say if player on ground, or what is it called? Is on ground. What is it called? Is it not here? It is here, right? If we're on the ground, is it inside the? It sure is. Whoop. So if we're on the ground, then we. Whoop. Aha! Okay, that's a little better. So when we land on a new platform, we will lerp the camera to that level. See? And this is like way too, because this is 100 FPS. How do, I'm trying to remember the formula. I didn't pull up like a Chrome window before this. But you guys know what I'm talking about. You guys know. It's the nice thing where it's the like frame rate independent lerp. It's like POW, like 1 minus delta time or some crap, and you. Oh, I don't remember. I should shush before I say the wrong thing. But yeah, so here's our little, not bad for an hour from scratch with SDL, in a baby programming language, but yeah, so not too shabby. when next you see this game, it will probably look more like an actual game. But this has been encouraging, I think, at least for me. Like, being able to do a demo like this feels pretty neat. I don't know. Anyway, we can of course go and change our level, right? We got all the way over here and then didn't do anything. So let's go over there and we'll get up to this part, and then we'll go and make like a we'll make like a big hard jump or something, and then and of course it's gonna put me all the way back. I could have it not do that. It's like here's the cool thing about playtesting, right? Is we can go to the events processing and we can go to our reset and we can do this cool thing called cheating, where we turn this off and now I can refresh and it's fine because and I don't get warped away, right? It's pretty sweet. Well, I screwed that up. Oops. Put it back. Okay. But yeah, we're having a grand old time. And here's our little world. We could also do something where it's like, oh, if you've been off the ground for a long enough time, we would start like having the camera follow you. Also, we didn't bounce check. We didn't bounce check our solid check up there at all in this. We should bounds check this actually. That is an important thing to do. So we'll say if x is less than 0, or x is greater than or equal to width, return false. We'll let you go outside the bounds because it's a platformer, and then we'll do the same thing with y. Height. Oh, these have to be casted. Oh, yeah, that's right. Oh, these don't need to be casted at all, but I guess we casted them. These need to be casted. Okay. Anywho's. Oh no, it's not. Why is my camera not working? What the heck? What did I break? How did I do that? I'm landing on platforms, mister. Aren't I? Okay, let's reset the camera when we reset the player. Actually, we just do this. Oh, what's the problem? Oh, I didn't export it. My bad. There we go. Yeah, I just fall through the ground, that's why. How did I just do it in reverse? Less than 0 or greater than the thing. Well, what's the oh, duh. Duh. Yep. So we actually don't need to cast that. We need to cast these guys. It's the tile X and the tile width that is the problem. Oh my goodness. These need to migrate in here. So we would say if the tile X, Lord, what a mess. If the tile X is less than 0, or the tile X is greater than or equal to the width, we return false because it's out of bounds. And we do the same thing. With the Y. Doi. How simple of me. Okay, so now we have our cool jerk who can't make simple jumps. We have our little didgeridoo. Oh my god, this is embarrassing. But we could do something like, you know, we could have a timer in the player data where we're like checking the flight time, and if it's above some certain amount, then the camera would move to track the player or something like this. There's just a lot of stuff that you could do with that. But yeah, not too shabby. Thanks for watching. The whole point of this project is to give the joy of programming back to myself, and I think I'm going to succeed on that front. I feel encouraged in a way I haven't in a long time. I hope other people find this interesting. I'll have more to show about projects made with this setup soon. But yeah, thanks. Bye-bye.